Hello everyone, welcome back to my YouTube channel. In this video, we shall be learning about the determination of force constant and the type of bond. A diatomic molecule consists of two atoms with masses of m1 equivalent to 2.0 times 10 to the power of negative 24 gram and m2 equivalent to 3.2 times 10 to the power of negative 24 gram. The wave number of the vibrational mode of the molecule is reported to be 5854.4 per centimeter. Identify whether the molecules have a single, double, triple bond based on the calculated force constant. Alright, so the formula that you can use is actually by using the wave number, because the wave number is given to you in the question. So the wave number is equivalent to 1 over 2 pi c square root of k divided by m1 times m2 divided by m1 plus m2. So all of the values are given in the question, so you just have to plug in the values except for k, which is the force constant that we are going to calculate. So in other words, we can say that 5854.4 per centimeter is equivalent to 1 over 2 times 22 over 7, which is a pi, and then your c, which is the speed of light, is equivalent to 3 times 10 to the power of 10 centimeter per second. So this one you need to times with the square root of k divided by m1 times m2, and then you're going to divide that with m1 plus m2. So I'm not going to show you the calculation for m1 times m2, so you should get 6.4 times 10 to the power of negative 48. This one should be gram square, because m1 is in gram and m2 is in gram as well, so you times both numbers, so it's going to be gram square. And then m1 plus m2, you are going to get 5.2 times 10 to the power of negative 24 grams. So here you can slash out this, you will end up just having grams at the bottom of the equation. So in other words, you are going to calculate all this again, so you should get the value. This one is unchanged, 5854.4 centimeter per centimeter, so it should be equivalent to 1 over 1.8857 times 10 to the power of 11 centimeter per second, so to the square root of k divided by 1.2308 times 10 to the power of negative 24 grams. Right. So the next thing that we are going to do is we are going to lose this square root, so we are going to do square here and also square around here. So everything we are going to do the square to lose the square root for easier calculation for the k. Alright, so we are going to do the square around here. So what you are going to get here is actually equivalent to 3.4274 times 10 to the power of 7. So this one, because there's square over there, so per centimeter equivalent to 2.8123 times 10 to the power of negative 23. So the unit here is centimeter square over second square, because this one is actually the value for the speed of light times 2 pi, so the unit is centimeter the actual unit is centimeter per second because of the speed of light. So because you make it into square, so centimeter square over second square. So the other half will be, you just have to lose the square root, so it's going to be 1.2308 times 10 to the power of negative 24 gram. Right, so we are going to rearrange this, and you shall end up having K equivalent to 3.4274 times 10 to the power of 7 centimeter per centimeter per centimeter. And then the value of this value, you're going to bring it up, so times 1.2308 times 10 to the power of negative 24 gram, and then the rest of the thing you're going to divide with this value, which is 2.8123 times 10 to the power of negative 23 centimeter square per second. Right, so from here what we can do is, this one we have, and then we have another centimeter square around here, so we shall end up with gram per second. So we're just going to recalculate this value. Alright, so we slash this out and you'll end up with that. So after you put this value in your calculator, you will get K is equivalent to 1.5000 times 10 to the power of 6. So the unit will be gram per second. So you need to make sure that you get the unit correct. So this value, the value for the force constant, is actually referring to the force constant that matches the triple bond. So in other words, this diatomic molecule is actually consists of triple bond. So this is the final answer for this question. Thank you so much for watching this video from the beginning till the end. I'll see you again in the next video. Goodbye.